Okay, we're going to look at problem solving with sine law here. And instead of just pulling up a random question, what we're going to do is we're going to go to a question that was generated by a computer. And we're going to check to make sure this computer program is correct. So I'm going to read the line at the top here. It says in the top left corner there is a triangle XYZ. Side XZ is 10 millimeters, side ZY is 33 millimeters, and angle X is 44 degrees. Now it says find the measurements of the other angles, but more specifically it says angle Z is round to the nearest whole number, and they want your answer here. And the computer has generated an answer. The computer generates an answer saying it's 125 degrees. Angle Z is 125 degrees. We are going to try to prove this. So remember we have XYZ, XZ, YZ. I'm going to have to come back and forth, but I'm going to try to draw it out. So the very first thing I do when I go to draw one of these triangles, can I draw straight lines? I'll do my best here to draw some straight lines. Okay, so we have a triangle. Now this will not be to scale. I'm just drawing one, and I'm assigning letters to angles. So X, Y, and Z. And we'll say that those are the angles of the triangle. Now, what's important when we do this is we have to realize that opposite side of that angle is the side of that associated with that. So if this is angle Y, this becomes side Y. So the angle is opposite of the side, the lettering at least. So if this is angle X, that makes this side X. And if this is angle Z, that makes this side Z. Okay, so that's going to be really important when we're actually associating numeric values to angles and sides. So I'm going to draw another one to scale here. That was just our kind of our explanation. But let's go back and get our actual measurements. So I think the XZ was the first one. XZ is 10 millimeters. So that means from angle X to angle Z. Wow, that's really specific. I was much nicer in that explanation. XZ is 10 millimeters. Okay. This is also known as side Y, just as we showed in the 2 seconds ago. Side ZY is 37 millimeters. So ZY or YZ is 37 millimeters. And most importantly, angle X is 44 degrees. So angle X is actually opposite of the 37 millimeters. This is 44 degrees. Now remember, they've asked us to solve for angle Z. And that's just what they want to know. So this is the unknown. The problem here is we're going to use sine law. And if I write out sine law real quickly, I'll do it with X, Y, and Z here. So sine, we'll say X for the angle over side X is equal to, okay, so it's essentially a ratio, sine Y over side Y, which is also equal to sine Z over side Z, okay? We can associate our values here just like we named them before. Our angle X right here is our 44 degrees. So we can take that out. Let's see, I'll shrink this just a little and move it up. So sine 44. And we also have side X, which is opposite of it, is 37 millimeters. So we're just going to put in 37 below. So that's great. We have an entire ratio, which means that's awesome. We can actually use sine law. Let's take a look at our Y's here. Y angle is unknown, but the Y side we have is 10 millimeters. So sine angle Y we don't know, but the side is 10 millimeters. Okay. We have one unknown. That's great. We can go to solve that. And side Z, well, we don't know what it is, and we don't have a measurement of the side either. So this one here, we essentially, I'm going to write it in. We have two unknowns. We're going to drop this one off. We don't need it. It's not going to help us. We're going to focus on this Y. And once we have that angle, we know all the internal angles of a triangle. So angle X plus angle Y plus angle Z will all equal 180 degrees. We already have angle X, so we know that's 44. We just need one other angle, angle Y, and really I know they're looking for angle Z. But once we get angle Y, we'll be able to isolate for angle Z. I know that looks like L's, but those are supposed to be symbols for angle. I gotta work on that. Okay, so let's go back to this. Let's make sine 44. Yeah, let's go to our next page here. Make a new page. Great. So we had sine 44 over 37 was equal to sine of angle y, which was unknown, over 10. Great. What I want to do is now we want to isolate this here. We want to isolate this y. Okay. So I can cross multiply, and I end up getting a value on this side. Oh, I don't want that. That I don't want. I reiterated. What I'm going to do is I'm going to take this, and because this is a division sign, I'm going to multiply this side by 10 and this side by 10. It's also known as like just bringing the 10 over here. What happens is they'll call it canceling out, but it's essentially creating a 1, and a 1 divided, something divided by 1 is still just itself. So we'll be left with sine y on this side. And over here, I'll have 10 times sine 44 over 37. I can rearrange that. Technically, I can make this, I can say, or 10 over 37 times sine 44. These are actually the exact same things if you're familiar with your fraction rules, but either way, we've got that there. And the reason I rewrote it like this is because we're going to go to a calculator that'll help us a lot when we write it this way. So let's go to my calculator here. So if you need a scientific calculator, you don't need to buy one as long as you have internet access. So Desmos Scientific Calculator. And we said, I say 10 divided by, that's a minus sign, divided by, here you go. What else did I write? 10 divided by 37. 37, great. And look, I can even touch the screen, move it over, times sine of 44. Whoops. Sine of 44, end brackets. And it's already given me an answer. This is great. What I'm going to do from there is, I'll show the next step. That's 0.1877. So this whole side becomes 0.1877 is equal to sine of y. Essentially, all of that became this answer down here, okay, after we calculated it out. Now, to isolate the y, we find the inverse of sine, so we get actually sine to the power of negative 1. And this is our ratio value in those brackets is equal to, this will be the angle of y. There's a whole explanation to how we're technically dividing by sine, and you can use the negative exponent to flip it up, but we'll just go with that is our quickest way to do that. So on a calculator, if you're solving for an angle, just make sure you have, whether it's sine, cos, tan. If you're looking for the angle, it's that that word, I guess, to the power of negative 1. So let's put it back in our calculator. What's nice about it is we can save our answer from before. I can start a new line. I still have my answer. I'm going to say I need the inverse. There we go, sine inverse of my answer from above. Perfect. Brought it right back in. And it gives me a value, 10.82. Oops. 10.82. Great. So y, let me move this up here, y is equal to 10.82. And remember, this is degrees. That is a terrible 10. Let's try that again. 10.82. Nice. But remember, if we're looking at our triangle, this is side x was 44. We just found angle y, which is 10. I mean, we could say it's 11.82, but what they want is angle z here. There's my z. So this is what we're trying to find. And we said before, we know that 180 degrees is equal to angle z plus angle x, and I'll put a value in for that, it's 44, plus angle y, which is, I mean, let's call it 11 to make it nice and easy. Okay, so we can isolate. We can work on isolating here. If I were to move 44 to the other side and 11 to the other side, essentially we'll subtract by 44 both sides and subtract both sides by 11. It'll end up as this, 180 subtract 44 subtract 11 is equal to the angle z. And I can go right back to my very handy calculator. So 180 subtract 44 subtract 11. Now I did round, hey, 125. That's exactly what the computer told us the answer was supposed to be. So our angle z in this case is 125 degrees. Great, so we have everything there. And just to give you an overlap one more time, so that's where we started, and that's where we ended. Okay.